Hello, this is a demonstration of regression analysis questions as required on the Aqa S1 syllabus, and I'm going to use the June 2010 question to demonstrate this one, question 6, to demonstrate the process. Okay, as ever, the first thing we do is read the question. During a study of reaction times, each of a random sample of 12 people aged between 40 and 80 was asked to react as quickly as possible to a stimulus displayed on a computer screen. Their age X in years, ages, and reaction times Y in milliseconds are shown in the table. So here's our data. Okay, so we should have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people. So the first person there is 41 years old, and the reaction time was 520 milliseconds. Okay, so let's have a look and see what the question asks us to do. Calculate the equation of least squares regression line of y on x. Okay, so this is one we can do with our calculator. So let's quickly do that. What do we have to do? Let's open up a calculator. Here, if we go to menu, stats, we can enter all the data. List the X, all the list X is going to go in list 1, all the X data, and the Y data is going to go in a list 2. Okay, so then we're going to do let's go back to where you would be. We can firstly look at it as a graph. There's our scatter diagram. We can then calculate the X linear correlation. Now on your calculator, which is the 98702, I think you'll get a choice of whether you did a correlation with an A plus BX or a choice of AX plus B. Usually we'd advise you to do A plus BX because that's what you're used to. Okay, but now we've got the results on the screen either way, and we've got here that we've got an A value at the top there of 3.25. 5 if we round it to 3 decimal places, and the B, so that is our gradient, as we can see there, because it's the AX plus B, and then our intercept, so when x equals 0, y equals 501. So I'm just going to write that down because that's going to be our correlation line. So let's just move that down on the screen and write that out. Y equals 3.25. Let's get the calculator back on the screen. 3.255 x plus 501, what was the decimal place? 501.4. Okay, so we can see that because what we've done is we've written here y equals ax plus b from our calculator, and we've just substituted in the numbers. So there is our correlation line. So that's the first part for, our regression line, our least squares regression line. So there we are, and that's our 4 points. The next part of the question asks us to BI, draw your regression line on the scatter diagram on page 16. Okay, so let's get a scatter diagram up, shall we? Okay, so I've got the diagram here on the screen, and now we've got to draw our line on it. So what's the best way to start? The best way to start is here by putting our intercept point on the left hand side. What do we have as a formula? Let's just write that out here so that we can use it again all the way through. It was that y equals, was it 3.25 x plus 501. So let's start with our intercept. So what's the value when x equals 0? Our y value equals 501. Let's see what we've got here in the bottom corner. So that's our 0 position. Can't go down to our 0 position. So what's our first point? Our first point on this diagram is 40. So let's do when x equals 40. What's our y value going to be? It's going to be equal to, excuse me. Okay, so when x equals 40, y is going to equal 3.25 times 40 plus 501, which equals 631. So looking up our column of 40, which is where our A value is here. Let's just check that. Yeah, A value is just to the left of that. It's the 5th row. 5th across, 6, 3, 1. So there's a point. So that's one end of our correlation line. Okay, let's go to the other end of this. Let's have a look at 80, shall we? So when x equals 80, which is this right hand edge of the graph, y will equal 3.25 times 40 plus an additional 501, which equal, sorry, I said 40 there, I meant 80, so 3.25 times 80 plus 501 gives us 761. So that's our right hand column here, 80, and we're going to come up to 7,246, coming across here 6, so that's going to be our second point. So we can see our 2 points now, and I'm going to draw a straight line between them. Okay, there's my straight line between the two, between our 2 points. So that's the simplest way to do it, isn't it? Find 2 points that are on, 2 x values that are on the graph, and then calculate the y values, mark them, and then draw a straight line between. That's the easiest way to answer this. So there is our graph and our correlation, regression rather, between the two. What can we work out from this? Let's have a quick look up and down. Here we've got some big outliers here, haven't we? Well away from our regression line, H, D and I. What have we got down the bottom? And we've got one right down the bottom, E here, which is well below the graph. So we've got 3 above the line and 1 below the line rather, and that's having a significant impact on the graph. If we go back to our calculator, we found that our R value here was only 0.176, which means there's a pretty low correlation here. So let's have a look at R, 0.176. Okay, so there we are. That's our 2 points for that. Now let's go and look at the final part of this question. Here we go. Comment on what this reveals. I would start this normally with a comment statement along the lines of the regression and the changes. So here we would start with, here we go, on average, so this is the one that I want you to use, on average for every 1 year increase in age, we're looking at here, it's reaction time, wasn't it? Reaction time. Time increases, in this case it's increases by, what do we have here? It was by our A value. What do we get for an A value? We got 3.25 by 3.255 milliseconds Okay, so that makes it clear that one's affecting the other, that there is a correlation between the two, there is a regression, and there's a trend between an association between the two. So I think we should use the word association at this point for that. That's the association that we are using. Okay, however, in this case, I'd be adding a second line about reliability. However, the correlation is, now we've got a choice between strong, moderate or weak. In this case it's going to be weak. Is weak as demonstrated by the correlation coefficient PMCC, product moment correlation coefficient R, of only 0.176. Let's just check that is the right number, isn't it? 0.176. Okay, and here, just going back to the graph, I think we would want to know what's doing that. We'd say they are significant outliers. Significant outliers. That is far away from the regression line in the data. Okay, here's a quick summary page on regression. It's also known as the regression line is also known as the least squares regression line, because that's how the formula generates it. Least squares regression line. As usually we use the form y equals a plus bx, and you can get that off your calculator. Best way to carry out this is to calculate it using the calculator, enter the data, and then find your a, your b, and also just write down your R figure for the correlation, the reliability calculation. Secondly, they ask you to draw the regression line onto a scatter graph. You can do this by calculating 2 points, one at the left-hand end of your graph and one at the right-hand end of your graph, and then draw a line between them, straight line between them. Okay. Third part is context statements. You want to be ready to routinely add a statement along the lines of, on average, for every xx, whatever that value is, increase in the x value, there is a yy increase, straight decrease in the y value, because it could go up and it could go down depending on what's happening, what that the gradient function is. Okay, and then you would follow it up with a comment on reliability. This is reliable or unreliable because the correlation coefficient equals whatever the value is that you've got out of your calculator. So the correlation is either strong, moderate or weak. So if it's a strong correlation, it's a reliable conclusion. If it's a weak so if it's a low correlation, if it's a weak correlation, it's unreliable. Okay, and finally, all the formulae for this are in the AQA formula book, so that if they start giving you SX's and SXX and SXY's, if they gave you the individual numbers, the SXY and SYY, you could actually go through and do the calculation from the formula book. But that would be the only circumstance you would do it, is if they give you those figures. Okay, I hope that's useful to you, and thank you for watching.